lesson is really long. As I said, it's several pages. And we're just going to take it one day at a time. We're just going to start with the first and back page today. So 6.5 is on factoring. We've done a little bit of factoring strictly in the quadratics unit, but we're going to look at some new types of factoring and some different ways to factor. And the first thing that we need to do is to get some practice factoring by GCF. What is a GCF? Greatest common factor. So we want to know the biggest thing that we can divide each of those by. And so like on number 1, when we're doing the GCF, we look at both the numbers in the front and the variables. So based on 12 and 2, what is the GCF of 12 and 2? What? 2. Really, the only thing you could divide both of those by is 2. And then you look at the variables. So this first term has x cubed. This one only has x. How many do they actually have in common? Just one x. So the GCF is 2x. And what we're going to do is divide both of these terms by 2x. And the way we write our answer is by putting the GCF on the outside, and then inside of the parentheses, we put whatever we get when we divide. So if I take 12x cubed divided by 2x, what do I get? 6x squared. Good. Because 12 divided by 2 is 6. And then I have x cubed on top and x on the bottom. So when I cancel out one of the x's, I'm left with an x squared. What is 2x divided by 2x? 1. Not 0. It's 1. So plus 1. And this is your answer. No, because all the x's canceled. Yep. All right, number 2. What is the GCF? So what between 14 and 7, what can I divide both of those by? 7. And then how many x's do they have in common? 8. So x to the 8. So I'm going to divide both of those by 7x to the 8th. So your GCF goes on the outside. If I do 14 divided by 7, I get 2. And then the x to the 8ths completely cancel. Minus, what's 7 divided by 7? 1. And then x's, when I cancel x's, how many am I left with? 3x cubed. Now all of these, we don't want to write our answer as individual, like fractions like we had been doing, because with all of these GCF problems, if you actually get the GCF, you'll never have anything left on the bottom of the fraction. So that's why I'm not stressing that so much. Now on this one, you can put the 1x cubed, but the 1 is not necessary. Okay. Number 3. This time I have 3 terms, so I have to find something in common with all 3. So what can I divide all 3 of those by? 2. And 2 is the only thing. Now sometimes you could divide by 2 and something bigger. We always go with the bigger option. But on these, the only thing that you can divide all 3 by is 2. Now what about variables? How many variables do they all three have in common? The last one doesn't have any x's at all. So they don't have any x's in common. So the GCF is only 2. So we're going to divide each of these by 2.
So all the x's will just set aside?
Yes. Yep. So what's 36 divided by 2? 18. That one still has x cubed because we didn't divide out any x's. Plus 7x plus 9.
What would we do if there was an x next to 18?
Then our GCF would be 2x.
What about the 30 for 36x?
So then if we were dividing by an x, this would be x squared, and then those x's would have canceled out.
So wouldn't we go on with 2x?
Yeah, we would put 2x down there. If this one had an x, then our GCF would be 2x. So we'd divide all of them by 2x. Number 4, we have x's and y's, so we just look at both variables. Look at your numbers first. What can you divide 15 and 24 by? I'll talk about that in just a minute. What can you divide 15 and 24 by? 3. Can you divide them by anything else? No. So it's 3. If your very first term is negative, we want to divide by negative 3. So if you always look at your first term. If your first one is negative, your GCF needs to be negative. How many x's do they both have in common? This one has x cubed. That one only has x. So they only have 1 in common. What about the y's? How many y's do they both have in common? 1. So just 1 y. So my GCF is negative 3xy. Yes.
So, like, what would you do if it was written as, like, negative 15x cubed and, like, 24y4? Like, you didn't have both x's.
So if we only had one x is here and y is here, your GCF would only be negative 3. You wouldn't divide out any variables in that case. They have to have the same variable in common. So we have negative 3xy. I'm going to divide both of these by negative 3xy. What's negative 15 divided by negative 3? Positive 5. And then I'm dividing out one of the x's, so I'm left with x squared. The y's completely cancel. And then what's 24 divided by negative 3? Negative 8, so minus 8. The x's cancel here, and then when I cancel one of the y's, I'm left with y cubed. That's...
Why would we cancel an x and not both the y's?
Well, on this first one, I have 3 x's in top and 1 in the bottom. So when I cancel out one of each, the top still has 2 left. So that's where it has x squared. But the y's, we cancel separately. This one, I canceled out all the y's. And then back over on this side, I had only 1 x top and bottom, so those completely canceled. This one, I still had y's left over.
So why does the GCF have to be negative 30, not just 30?
You generally want to look at your first term. If your first term is negative, go with that.
What about the second term?
That one, just worry about the first one. If the first, is it wrong? No. But if you have a multiple choice test, this is going to be your option.
Would you get the same answer?
Well, if you just put a positive 3 here, this would be positive, this would be negative, and this would be positive. They technically all mean the same thing, but this one is the better way to write it. And it is easy to check your answers. So my question and what I have factored, those are the exact same thing. They're just written differently. This is what we call completely factored. If you want to check your answer, store a number for x and y. So 2 store x, 3 store y. And then type in your problem, negative 15x cubed y plus 24x y to the fourth. And then type in what you got as an answer. And see if they match. Now, if you had made your GCF a positive 3, that would have been positive, that would have been negative, that would have been positive, you still would get the same answer here in your calculator. So I won't count it wrong if you do that, if you have all these signs switched. But if it's multiple choice, you have to know this is the one you're looking for. Number 5, we have 3 terms. So look at your numbers first. What can you divide 2, 6, and 4 by? Just 2. Now look at all 3 of them. How many x's do they all have in common? 1. This one has 3. This one only has 1. This one has 2. So they only have 1 total in common. And then what about the y's? How many? Just 1 y. 2xy, 2xy, 2xy. What's 2 divided by 2? 1. X cubed divided by x? X squared. What's y divided by y? It cancels out. Minus 6 divided by 2? 3. And then x's cancel, y's cancel. So it's just minus 3. Plus 4 divided by 2? 2. So one of the x's cancel, one of the y's cancel. So plus 2xy. And number 6, what can you divide 15, 3, and 5 by? Can you take 5 divided by 3? No. Is there anything you can divide all 3 of them by? No, besides 1. You can't take 5 divided by 3. You can't take 3 divided by 5. So, I mean, you can, but you get a decimal. We want to get whole numbers. Yeah. What about x's? How many x's do they all 3 have in common? Look at that middle term. Does it have any x's? No. There's no x's here in the middle term, so no x in your GCF. What about y's? How many do they all have in common? This last one only has 1.
Oh.
So the y, this one only has 1 y. So they only actually all have 1. So your GCF on this one is only y. So we're just going to divide all of those by y. So basically, when we're dividing by y, everything stays the same except one of the y's is gone in each of those. So when I divide this first one by y, we're left with 15x to the fourth y plus 3y to the fourth plus 5x squared. Do I have any y's? No. And this is your answer.
So you just find whatever you got.
We got to find whatever every term has in common. Any questions on that? Then we're going to do difference of squares today. That's all we're going to be doing today. We've talked about perfect squares as far as the numbers go. 1, 4, 9, 16, 25, 36, and so on. Those are up there on the board. But variables can also be perfect squares. In order to be a perfect square, the exponent must be divisible by 2. So your exponent does not need to be a 4, a 9, a 16, 25. It needs to be an even number. And if I want to take the square root of something, of a variable, we divide the exponent by 2. So if I say, what is the square root of x squared? It would be x to the first power, because 2 divided by 2 is 1. Or just x, which is just x. The square root of x to the 10th would be x to the 5th. You no longer need to put the square root symbol. When you take the square root, that symbol goes away, and you don't keep taking the square root. The square root of x to the 16th is x to the 4. No, not 4. 8. The square root of regular 16 is 4, but not x to the 16th power.
So you just
Divide by 2. Yep. And then the square root of x to the 24th is x to the 12th. So you'll need to know that for these problems. Oh, okay. So a difference of squares. What does the word difference mean? Subtraction. So these are the types of factoring problems that we will have when we have a subtraction problem, and both things that I'm subtracting are perfect squares. So they're either one of those perfect square numbers, which I can list over here if you want to write them. Those are perfect squares. So you've got these numbers or variables that have an even exponent. Any of that is considered a perfect square. So if my problem is a squared minus b squared, it only works with a minus. So I have something squared minus something else squared. In order to factor this, I'm going to get in 2 sets of parentheses. It's going to be a plus b, a minus b. So we're going to find the square root of each side to get my a and b. And then we write our answer as a plus b, a minus b. Number 7, I have x squared minus 25. Number 1, is it a difference? Yes. Are both of these perfect squares? Yes. So it's a difference of squares. So I'm going to find a, and that is the square root of this first one of x squared. What is the square root of x squared? X. B, I'm going to find the square root of the 25. Just ignore the negative when it is 5. So my answer, it's A plus B, A minus B. So x plus 5, x minus 5. Number 8. Is it a difference? Yes. Are both of those perfect squares?
No, the 6 and the perfect square is
It's an exponent of 6. How do we know if this is a perfect square? How do you know if it's a perfect square, your exponent will be a multiple of 2? Is 6 a multiple of 2?
Yes.
Yep. So x to the 6 is a perfect square. 64 is a perfect square. So my A is the square root of x to the 6, which is what? Don't say 3. X to the third power. B is the square root of 64, which is 8. So my answer is x cubed plus 8, x cubed minus 8.
What did you type in for square root x6? Because for some reason I got 260.
Yeah, because when you can't just type that in your calculator, because your calculator is plugging in a random number for x.
So it's just
Over
divided.
here, you divide the exponent by 2.
Yep. So I don't have to worry about that. It's still just dividing that.
Yes. Yep. If you have a variable, you can't just type that in the calculator. Now, what you can type in your original problem and type in your answer and see if they match. Doesn't really matter what number you get. That all depends on what's stored for x. But if they match, it's correct. If I were to give you this problem and tell you to multiply it using the box method that we had been doing, you would get x to the 6 minus 64 if you did it correctly. Number 9, do we have a difference? Yes. Do we have 2 perfect squares? Yep. 49 is a perfect square. X to the 8th is perfect because the exponent is divisible by 2. Yep, so your A is the square root of 49. Your A is always the square root of the first one. What's the square root of 49? 7. B is the square root of x to the 8th, which is, it is not 4, it's x to the 4th power. So your answer is 7 plus x to the 4th, 7 minus x to the 4th. Are there any questions? Oh, go ahead.
What would you do if one of them wasn't?
If one of them is not a perfect square, we'll get to those. That means there's probably a GCF. And we'll divide out the GCF first, and then notice we'll have difference of squares. We'll do some of those examples in just a minute. Don't know if we'll get to all of them or not. Like the back page. Not all the rest of the notes, but maybe we'll get to some of the back. All right, number 10. Do we have a difference?
Yes.
Is there a subtraction sign?
Yes.
Yes. Do we have 2 perfect squares?
Yes.
Yes. So A is the square root of 100, which is 10. B is the square root of x to the 16th, which is? No. X to the 8th. When I give you an exponent that's a perfect square, that's going to throw you off. You divide by 2. When it's the exponent, divide by 2. So my answer is 10 plus x to the 8th, 10 minus x to the 8th. If you put the minus first and then the plus, that's also okay. Any questions? I put a space here on the side for you to jot down your perfect squares. That'll just help you. So fill those in. One, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. You really should have those memorized, at least up to 12. All right, number 11, do we have a difference?
Yes.
Yes. Is everything in here perfect squares? Yeah, got more stuff to look at, but it's all perfect squares.
So is this the same as A plus
Yep,
B?
yeah, we're still on that one. So A is the square root of 9x to the 6th. So you just do them both separately. The square root of 9 is 3, and the square root of x to the 6th is x to the 3rd power. So 3x cubed. B is the square root of 36, y to the 16th. What is this? 6, y to the 8th. Perfect. So my answer is 3x cubed plus 6y to the 8th. 3x cubed, minus 6y to the 8th. And I actually messed up. What you're really supposed to do is always look for a GCF. And I saw 9 and 36 and was like, oh, those are perfect squares. But both of those are divisible by 9. We actually should have factored out a 9 first. We should have divided both of those by 9 if I was paying attention.
I thought you just divided them by what their square was.
Well, before we even got to this step, we should look for a GCF first and then do that. So we'll pretend that I didn't mess that up, and we'll go on to number 12. Notice on number 12, 2 and 32 are not perfect squares. But what are they both divisible by? 2. They both have a GCF of 2. So we're actually, before we even do the whole difference of squares, we're going to divide those by 2. So if I divide by 2, just like we did with the GCF, we're left with x squared minus 16. What I have in parentheses, are those perfect squares?
Yes.
Yes. So when I do my A and B, I'm going to base it on what's left here in parentheses. So my A is the square root of x squared, which is B is the square root of 16, which is 4. We do have to remember to bring down the 2. That is part of your answer. It goes on the outside, just in the front. And so then we have x plus 4, x minus 4. I'm going to make a note really big over here. Look, you can't see that. For GCF first. Every problem we do, you should do that first. So you need, before you even start doing any other factoring, you always need to look to see if there is a GCF. See if there's anything that they all have in common. So number 13. No, I got number 3. Is there a GCF? Yeah, there would have to be because 12 and 27 aren't perfect squares. So it is 3. So if I divide this first term by 3, what do we get? 4x squared, perfect, minus, what's 27 divided by 3? 9. Now do I have perfect squares? Yep. So a is the square root of 4x squared, which is 2x, perfect. Y'all are letting Walker answer all the questions. B is the square root of 9, which is 3. So my final answer is the 3 from the GCF. And then 2x plus 3, 2x minus 3. Are there any questions? Number 14, is there a GCF? There has to be a GCF. And what do you think it is? 5. Yep. 20 doesn't go into 125. So it is 5. They don't have any x's in common, so just 5. What's 125 divided by 5? 25. So 25x squared minus 4. So a is the square root of 25x squared, which is b is the square root of 4, which is 2. So my answer is 5 from the GCF. And then 5x plus 2, 5x minus 2. All right. We're going to do 2 more. Let's do number 15, and then we'll do 17. 15. I see perfect squares right off the bat. But we still need to check for a GCF, kind of like number 11. I messed you up. So is there anything that you can divide 64 and 100 by? You can divide by 2, right? 64 divided by 2 and 100 divided by 2. But that doesn't give us perfect squares. There's actually a bigger number. It's actually 4. What about variables? Do they have any variables in common? They have what? One what? 1x. So the whole GCF is 4x. And so this leaves 16x squared minus 25. So A is the square root of 16x squared, which is
4x.
B is the square root of 25, which is
5.
So then your answer, you've got the 4x from the GCF, and then I do 4x plus 5, 4x minus 5. All right, number 17. What is the GCF? It is not 2. 17. We're skipping. We don't have enough time to do all of these. So I'm down here. 5. Yes. What about variables? X cubed. Yep. The most they have in common is x cubed, and then the most y's they have in common is just 1y. Right. So when I divide by 5, we get 25. All of these x's come out. All of the y's come out. So it's just 25. Minus 9 x to the 4th, y to the 2nd. So A is the square root of 25, which is B is the square root of 9x to the 4th, y squared.
3x to the 2nd, y.
Perfect. 3x to the 2nd, y to the 1st power, or just y. And so your final answer, 5x cubed y, and then we have 5 plus 3x squared y, 5 minus 3x squared y. And we'll stop there.